two ways to make the logic for the player to jump. One of these ways is to use more or less what we've learned right now. Okay, we could do something like if input.getKey, and then we type up as a string. We can just type transform.position plus equals vector3.up, so it's a direction that is going to point upwards, multiplied by speed multiplied by time dot delta time. Okay, then we can save this, we can go to Unity, wait for the compilation to be complete, and if we press the up arrow, then we're going to make the player to move up. But then we would have to implement the logic to apply the gravity and make the player to move down all the time. Then we would have to worry about collisions. So instead of doing this, okay, instead of writing all of these logic, let's remove that. We can use something that's already implemented in Unity. Okay, we can use the physics system here. So it's going to make our lives much easier. So first of all, we need to add a floor here. Okay, in our hierarchy, we're going to right click, select 3D object and then cube. We want to rename this cube to floor. We want to set its position to be 0, 0, 0. And we want to change its scale so it resembles a floor. Okay, so it's going to be kind of a very thin sheet of paper. So I'm going to change the scale on X to 10, on Y to be 0.01, something very thin, and on Z to be 10. Okay, so we have a very simple floor in here. Okay, now let's make a quick test. If we get a player and move it up, and if we press the play button, notice that the player is just hovering there. Okay, it's not falling. Physics are not being applied. Let's bring the camera a bit closer just so we can see this better. Okay, so let's change its Z position to -6. Now let's try that again. Okay, so there we are. The player is there, but it's just flying around. It's not falling. This is happening because we specifically need to tell Unity that we want this game object to respect the laws of physics. We need to activate it. And we need to do this because, well, physics are they execute expensive operations. There are lots of calculations being done all the time, just as we were about to implement. Okay, so we need to be very sure of what we're doing. Now, we want to select the player game object. Here in the inspector, we click on add component, and in the search field, we're going to search for rigid body. Okay, and after that, we just click here on rigid body, and that should be enough to apply physics to this cube. Okay, we have a few properties here. We can see that we can set the mass, the drag. We can set if we use gravity, if you want to do collision detection, and things like this. Okay, and now that we have this, if we press the play button, just by adding this component, the cube now falls and stays on the floor. Okay, we can still move it to the left and to the right, but we need to work on the jumping logic. So how do we do this? We need to go back to our code. So instead of using input.getKeyUp, let's use input.getKeyDown, and we want to pass space as a parameter. Okay, and now that we are here, we need to apply what we call a force to the player. Okay, so imagine we have this cube here. To make the jump, we're going to kind of kick this player, this cube, upwards. We're going to apply one single force at one exact moment of time, so it's going to have its velocity changed to a vertical value. Okay, so to do this, we're going to need a variable here. We're going to type public float jumping force. Okay, so let's start by setting this to 10F. Okay, it's going to be 10 units. We're going to save this, and when getKeyDown is triggered, we're going to require to access this rigid body of the player. Okay, so right now we have this rigid body component, but we are in the player component, and we need to access the rigid body. To do this, we need to type here get component. We're going to type the lesser than and the greater than characters, and between them we're going to type rigid body. So we're going to get the rigid body component, and the important thing here is this is a method call. We're specifically telling what is the type of the component that we want to get here, and we open and close parentheses to call the method, and well, we don't pass any parameters in here. Now we use dot to access that rigid body, and we're going to call the method add force. Okay, so there are some signatures to add force. Okay, there are different ways. You can apply a vector 3, or you can specifically tell the x, y, and z values here. Okay, so the horizontal force that is going to be added is going to be 0. Okay, we don't want to make the player to move horizontally. The vertical value is going to be the jump force that we just declared. Okay, jumping force. And the third value is going to be 0, because we just want to make the player to be propelled upwards, right? And if we save this and go back to Unity, we wait for this compilation to be completed, and now if we press the play button, if we press space, the cube is being propelled upwards. However, the force is very little. Okay, so in other ways, if you were studying this in a different manner, you would have to go back to the player code, change the jumping force to another value, then play again, then spend minutes trying to find the perfect number. But as we're using Unity and we made the jumping force public, we can just change that while the game is running to other values, like 100. And if I press space now, the player moves up a little bit more. Okay, well, it's not enough, let's use 300. Okay, so this is a nice value. Okay, so we can make the player to move to the left and to the right and jump in the middle of this process, okay, which is great. Okay, so we have this jumping force working as we expected. And notice that if this was get key, okay, so just get key, if we save this and go to Unity and try to play again, if you hold the space key, and even if you want to press, you are going to hold for a few milliseconds, you like it or not. Okay, so the force that would be added would be huge. Okay, so let's use 300 here. If I press space, the cube just vanished from the scene. Okay, I think there it is, it's falling now. Okay, so that happens if you do that. Okay, if you use just get key. So we're going to use get key down here. Let's save this jumping force at 300 so we don't have to set it again. Okay, and there is one more issue with this setup that we did with this input. Okay, even though it's on get key down, we can still release and press space again mid-air and make the player to kind of flap. Okay, this works for games like Flappy Birds, but we just want the player to jump once after they hit the floor again. Okay, so we're going to do a very simple collision check. Okay, so in the player, we're going to type void on collision enter. Between parentheses, we're going to type collision. We open and close curly braces. We do this because we're declaring the on collision enter method, and this is a specific name that Unity uses. We need to receive exactly one parameter, which is going to be collision, and we want to check if collision dot transform dot name equals to the string floor. That means we just hit the floor. So let's test that. We're going to type debug.log hit the floor. Okay, we do this because we want to check if the cube has hit the floor. So we save this, we go to Unity, wait one more time, and after this is completed, we press play. We have our cube, and once it hits the floor, we receive exactly one hit the floor message. If we press space, the player jumps. Once it hits the floor again, we receive another hit the floor message. So let's use that to our favor. Okay, so in player, we're going to type here private bool can jump equals to false. So we declare a boolean variable that is going to determine if the player is able to jump. Okay, it's boolean, so it's going to be either true or false. It's private, so other classes can access it, so that's internal, and it starts as false. Okay, and the jumping here is only going to happen if can jump is true. Okay, so this is what we're going to do. When we type that we want to check if space key is down, we also need to add another condition here. So the player can only jump if they press space and if this value here can jump is true. So we are going to type two AND characters. Okay, this is the operator for AND, and we're going to pass can jump. Okay, so we're saying that this conditional block is going to be executed if the left expression is going to be true and the right one is true. Both of them have to be true at the same time so this can be applied. And if the player hits the floor, we set can jump to be true. Okay, so we save this script. We move back to Unity and wait a little bit for this compilation to be ready. We press the play button. So we have the player false. We press space, and we actually have to, when we jump, okay, in the exact moment when we jump, we have to set can jump to be false. Okay, so here we set can jump to be false, Okay, so the flag is set to false, and then we have to fall again, and so we're able to jump again. Okay, so this time I press the play button one more time, and now if I press space multiple times, okay, I'm pressing several times here, but the player only jumps when they hit the floor. Okay, and well, we have a player that moves to the left and to the right. Okay, but what if we want to make this player to move differently? What if we want to make this player move like it was a card? Okay, so we want to be able to hold the up key and make the player move toward a certain direction. This is very useful for racing games, but also for virtual reality games, okay, because you're always facing one direction, and if you want to make the player move in that specific direction, well, you need to understand where the player is pointing to and make it move in that direction, okay, and also make the player to rotate. So let's work on this logic in the next video.